Hello and welcome to Mathematical Coaching Center, and today in this video we'll be discussing about the nature of the roots. Okay, this is from the chapter Quadratic Equation and this is the part 3 of the video, and if you have not seen the first two parts, the link will be given in the description. But before we begin, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing to this channel. You can also connect me in other social sites like Facebook and Instagram. So let's begin. The standard quadratic equation is given by ax square plus bx plus c equals to 0. Okay, now what do you mean by roots? Okay, before talking about nature of the roots, let's see what is a root. Okay, let's see what is a root. So the value of x that satisfies the quadratic equation, okay, given quadratic equation, is called the roots of this quadratic equation. Any value of x that satisfies the quadratic equation is known as the roots of the quadratic equation. Okay, let's see the other definition also. The value of x that we get after solving the quadratic equation is called the roots of the quadratic equation. Okay, so we have seen that when we solve the quadratic equation, we get two values of x. Finally we get two values of x. Okay, x equals to, there will be two values of x. That two values of x is known as the roots. Okay, that two values of x is known as the roots. Okay, for example, let's see, there's a quadratic equation x square plus 5x plus 6 equals to 0. Suppose this is a quadratic equation. Now we solve it by breaking the middle term. So we have broken the middle term, 5x into 3 and 2. After that we'll take out the common from the first two and the last two. Okay, this is the common, and after that we see x plus 3 is common on both, and we take out x plus 3 common, and this is something that we get. X plus 3 is common and x plus 2 we get after taking out common. So this is plus 2 and x, so it becomes x plus 2 after taking out x plus 3 common. So we'll do either or. Okay, we'll do either x plus 3 equals 0 or x plus 2 equals 0, and after that we get the values of x. Okay, and the values of x is minus 3 and minus 2. Okay, this is known as the roots of the quadratic equation x square plus 5x plus 6. Okay, so for a quadratic equation x square plus 5x plus 6, minus 3 and minus 2 is the roots. So this is a root of a quadratic equation. Moving on, let's see the coefficients of x square, x, and the constant c. Okay, the coefficient of x square is a, x is b, and the constant number is known as c. This is the standard form of a quadratic equation. This is the standard form of a quadratic equation. Okay, let's see a question. This has come in Madhyamik Pariksha 2018. Okay, so this says the equation a minus 2x plus 3x plus 5 equals 0 will not be a quadratic equation for a equals to, for which value of a will this equation not be a quadratic equation. Okay, the given quadratic given equation is a minus 2x square plus 3x plus 5 equals to 0. Okay, so for which value of a will this equation not be a quadratic equation? So most of the students, what they'll do is they'll directly write here 0. Okay, because we know that if a is not equals to 0, that it will be a quadratic equation. That means if a equals to 0, it is not a quadratic equation. But this is completely wrong. So why? Because this is not in the standard form. Okay, this is not in a standard form. Okay, so if such question comes like this, where a small a is already used, so what we do is we try to write the equation. Okay, we'll compare this equation with the standard form. So we'll write it something like this. We'll not write small letters a, b, and c because it is already used here in the equation, in this equation. So what we'll just do is we'll just write capital letter a, b, and c. Okay, we'll just write capital letters a, b, and c. So comparing this equation with this equation, okay, so this is the standard equation. ax square plus bx plus c equals 0. And why are we writing capital letters A, B and C? It's because small letter is already used here, so we don't want to get confused between these two letters. So just to avoid confusion, we are writing it in capital letters A, B and C. Now after comparing this equation, we get A, capital letter A as small letter a minus 2, comparing. Okay, B will be equal to 3, B will be equal to 3, and C will be equal to 5, C will be equal to 5. So this is after comparing. Now this standard quadratic equation will not be a quadratic equation when the value of a will be equal to 0, when this capital letter A will be equal to 0. That means this is equals to 0, when this value is equals to 0. Okay, so this equals to 0. That means taking 2 onto this side, what do we get? We get small letter a will be equals to 2. So what is the correct answer? That if a is equals to 2, then this equation will not be a quadratic equation. That means if you write 2 here, 2 minus 2 is 0. That means whole of this term will disappear and there will be no x square. At that time it will not be a quadratic equation. So this is how we solve when small letters are already given. We'll just take a standard quadratic equation with capital letters A, B and C. Okay, so moving on, a quadratic equation is this. Now the roots given by Sridhar Acharya's formula will look something like this. Okay, x is minus b plus minus under root b square minus 4ac by 2a. This is Sridhar Acharya's formula. So here the term that is inside the square root, that is b square minus 4ac, is known as the discriminant. Okay, the term b square minus 4ac is known as the discriminant. And why is this important here? It's because it helps us to see the nature of the roots. Okay, so after comparing with the standard equation, we'll get some values of b, we'll get some values of a, and we'll get some values of c. After solving this, we'll get some positive, negative or value that is equals to 0. Okay, that is known as discriminant. Okay, and how does it help to understand the nature of the roots? Let's see. Suppose there is this equation ax square plus bx plus c equals 0, and the discriminant that we get b square minus 4ac after solving is equals to 0. Okay, so if we get the value to be 0, then we can say the roots are real and equal. So this is the nature of the roots. Okay, what kind of root it is? It is real and equal when the discriminant is equals to 0. When we solve that b square minus 4ac equals to 0, at that time we say it is real and equal. After that, suppose after solving this part b square minus 4ac, if we get it to be greater than 0, so it is a positive value like 1, 2, 3, any positive value, okay, that is greater than 0. At that time we say the roots are real and distinct. Okay, roots are real and distinct. So every time we solve a quadratic equation, we'll get some values of x. In this case real and equal, it will be something like both the values will be real and it will be equal, like 3, 3. Okay, they are real. In this case it will real and distinct, like the example that we have seen previously, like we got minus 3 and minus 2, something like this. Okay, so it will be something like this. It is real but it is distinct, they are not equal. Okay, in this case they are both equal. So these are the two cases that we see. Okay, and the third one is when it is less than 0. Okay, when it is less than 0, then it becomes imaginary or complex. That is same as saying it is not real. Okay, it will not be real. So you can take a screenshot of this. It helps you to remember the nature of the roots. Okay, now let's see with the help of example. Suppose there is a quadratic equation 2x square plus 7x plus 3 equals 0. We need to discuss the nature of the roots. 2x square plus 7x plus 3 equals 0. For this equation we need to discuss the nature of the roots. So now we know we have to find the discriminant, that is b square minus 4ac. So for that we need to compare it with the standard equation, that is we will be comparing with the standard equation ax square plus bx plus c equals 0. Okay, so after comparing this, what is the value of a? A will be equal to 2. See, the value of a is equals to 2. What will be b? B will be 7. And what will be c? C will be 3. See, after comparing it with the standard equation, we get the value of a to be 2, b to be 7, and c to be 3. Now we have to find now b square minus 4ac. So what is b square minus 4ac? So b square, b is 7, so b square will give us 7 square. 4 is 4, a is 2, and c is 3. We'll replace the value and we'll get something like this. See, b square is 7 square, so 4a is 2, and c. We will always be using a bracket while replacing the value because it reduces the possibility of making an error. When there's a negative sign, you might make a mistake, so always use a bracket while replacing a value. So now 7 square is 49, and what is 4 into 2 into 3? It is 4 to the 8, 3 is 24, so we get 24. So while you multiply the numbers, you don't need to multiply the sign also. Here it is plus 2, and it is here it is plus 2, and it is plus 3. So 4 to the 8, 3 is 24, minus into plus is, it will give us minus. So now 49 minus 24 will give us 25. So what kind of number it is? It is a positive number. This number is greater than 0. So write it to be greater than 0. So now we are getting the discriminant to be greater than 0. The discriminant b square minus 4ac is greater than 0. So that means the roots are real and distinct. So this is the nature of the roots. So we just need to compare the equation first. We'll find the value of a, b, and c, and we'll see that the values is equals to 0 or greater than 0 or less than 0. Okay, if it is greater than 0, it is real and distinct, like in this case. If it is equal to 0, it will be real and equal, and if it is less than 0, it will be not real, or you can say it to be complex or imaginary. Okay, let's see a few more examples on this. So without solving, find the value of p for which the equation x square plus this has real and equal roots. Okay, so here also we'll be using the discriminant rule. It says real and equal. Real and equal means the discriminant b square minus 4ac should be equal to 0. Okay, the discriminant should be equal to 0. Without solving this equation, we need to say we need to find the value of p for which the roots are real and equal. So what is the condition for real and equal roots? It is the discriminant should be 0. So now comparing the equation ax square plus bx plus c equals 0 we have. So now comparing this to equation, this equation and this equation here. So we have a to be 1. So what is the coefficient of x square here? 1. What is the coefficient of x square? 1. Oh, sorry, it is a here, it is 1. And what is the coefficient of x? B, and it is here p minus 3. So b is equals to p minus 3. And what is c? C is here, it is p. So what are the values of a, b, and c? A is equals to 1, b is equals to p minus 3, and c is equals to p. Now since the roots are real and equal, here the condition is already given that the roots are real and equal. So now when the roots are real and equal, what do we have? We have b square minus 4ac is equals to 0. Okay, replacing the values, we get something like this. So b square, so b is p minus 3, 4, a is 1, and c is p. So this is what we get. Now this is in the form a minus b whole square. We'll just write the formula. It is a square minus 2ab plus b square. Okay, a square minus 2ab plus b square, and minus 4 into 1 into p is 4p. This is equals to 0. Okay, now let's multiply this. What we'll get? 2 into p into 3. Okay, after multiplying this, we get p square is equals to 2 into 3 is 6 into p is 6p. Okay, now there is minus 6p and 4p. We'll be adding this two, so we'll get p square minus 10p plus 9 equals to 0. So here we are getting a quadratic equation in terms of p. Okay, we're getting a quadratic equation in terms of p, and we'll solve by breaking the middle term. So now this 10 has to be broken in two parts, such that multiplication will give us 9 and addition will give us 10. So it is 9 and 1. So we have broken into two parts. After opening the bracket, we get minus into plus. Here it will give us minus, so minus into plus is minus, 9 into p 9p, and minus into 1 is minus into plus is minus, and 1 into p is p, plus 9 equals to 0. After that, from the first two we'll try to take out common, and from the last two we'll try to take out common. So from the first two we see that p is common, so it will become p minus 9. From the last two there's nothing common, so we'll take out 1. We are taking out minus common, so after taking out minus common from p, it will be plus p, and there is plus 9 here. After taking out minus common, it will be minus, because plus is equals to minus into minus. Okay, so plus, whenever you see a plus, that is it is minus into minus, so you are taking out 1 minus, that means 1 minus will be left out here. So this is what we get. Here we see that p minus 9 and p minus 9 are common, so if we take out common, so what is the remaining term inside the bracket? It will be p minus of 1, so it is p minus 1. So now what will we do is we will do either or. So either p minus 9 equals to 0. After that, taking 9 onto this side, we get p equals to 9, or p minus 1 is equals to 0, or p minus 1 is equals to 0. That means taking minus 1 onto this side, we get p is equals to 1. So what are the two values of p? The two values of p are 9 and 1. So therefore p equals to 9 and 1. So the question says find the value of p. Okay, so we have taken out the value of p to be 9 and 1, for which the roots are real and equal. Okay, this is how you solve this kind of question. After let's see one more example. The roots of the quadratic equation, ax square plus bx plus c equals 0. Okay, ax square plus 2bx plus c equals to 0 are real and equal, then b square equals to, here also many of you might make a mistake by writing b square equals to 4ac. Okay, but that is not the case again. Why? Because this equation is not in the standard form. Suppose an equation is not in the standard form, what we will do is we will compare this with an equation which is in a standard form. Okay, so we'll compare the equation with the standard form of equation, that is ax square plus bx plus c equals to 0. So this is in standard form. So here it is ax square. Okay, it's okay, but it should not be 2bx. Okay, this is not in standard form because it is not 2bx, it should be bx only. So as this small letter a, small letter b and small letter c are already used in the question, so we'll not be using that same. So we are using capital letters a, b and c to represent a standard form of quadratic equation. Okay, so after comparing this two equation, that is ax square plus bx plus ax square plus bx plus c and ax square plus 2bx plus c equals 0, what we get is capital letter a will be equals to small letter a, capital letter b will be equal to 2 small letter b, and capital letter c will be equal to small letter c. So this is what we get. Now since they are real and equal, okay, so what is the condition that we have? That b square minus 4ac equals to 0. Now again I am writing it in capital letters here. Okay, why? Because this equation is in standard form. Okay, this equation is in standard. This condition only applies to those equations which are in standard form. Okay, not to those equations which are not in standard form. Since this equation is not in standard form, we cannot apply the same conditions there. Okay, so this, because this equation that we have written here is in standard form, so the condition applies to this equation. So capital letter B square minus 4AC is equals to 0. Now replacing the values is what we get. Capital letter B is 2 into small letter b, so I'm writing here 2b square minus 4, a is a only, c is c only. Okay, now after opening the bracket, okay, while we replace the values again, we'll be using a bracket because it reduces the possibility of making an error. So this square is for both 2 and b, because that square is for everything that is inside the bracket. So 2 into 2 is 4, b into b is b square, minus 4 into a into c is 4ac. So this is what we get. After that, we can take out 4 common. So what we get is, after taking out 4 common, we have b square minus 4ac, and taking 4 onto the other side, it will be 0 by 4. And what is 0 by 4? It is 0. So the remaining term that we get is b square minus ac is equals to 0, and b square is equals to ac. Therefore, what is b square? B square is ac. So what will be the value here? It will be ac. So this kind of equation you can expect in the examination to come. I hope that this video was helpful, and in the next video we will be discussing on the lesson of relation between roots and coefficient. So to stay updated with our uploads, do subscribe to the channel and turn on the notification bell. Thank you for watching and have a good day.